Our planet Earth is a planet of water. Billions of years ago, life began in the vast oceans. The first life forms were tiny, single-celled organisms. These early life forms thrived in the warm, nutrient-rich waters. Over millions of years, they evolved and diversified, giving rise to a dazzling array of aquatic creatures. The oceans were teeming with life long before the first plants and animals appeared on land. From microscopic plankton to giant squid, the seas were a stage for evolution's grand drama. The first fish, our distant ancestors, evolved in these ancient waters, their streamlined bodies perfectly adapted to life beneath the waves. These early fish, like modern-day lampreys and hagfish, lacked jaws and paired fins. They were simple creatures, filtering food from the water or scavenging on the seabed. But they were the pioneers of the vertebrate lineage, the group of animals that would eventually conquer both the water and the land. The oceans were a cradle of life, but they were also a crucible, shaping the evolution of the creatures that inhabited them. As the environment changed, so too did the life within it, adapting to new challenges and opportunities. And it was from these ancient waters that life would eventually make its most remarkable journey, the transition from sea to land. The Earth is a planet in constant flux. Continents drift, climates shift, and life must adapt to survive. Around 400 million years ago, a series of dramatic changes began to reshape the planet, setting the stage for one of the most momentous events in the history of life, the colonization of land. The continents, once scattered across the globe, were slowly colliding to form a supercontinent called Pangaea. This massive landmass altered ocean currents and wind patterns, leading to drastic changes in climate. Many shallow seas, once teeming with life, began to recede, creating new and challenging environments. These changes had a profound impact on aquatic life. As shallow seas dried up, competition for resources intensified. Some fish were forced to adapt to increasingly cramped and oxygen-deprived waters. Others, in a remarkable evolutionary leap, began to explore a new and unfamiliar realm, the land. The transition from water to land was a monumental challenge. Air is much thinner than water, providing less support for bodies. Temperatures on land fluctuate far more dramatically than in the relatively stable ocean depths. And perhaps most importantly, water, the very essence of life, is far less abundant on land. The transition from water to land was not a sudden event, but rather a gradual process of adaptation and evolution that unfolded over millions of years. It was driven by a combination of factors, including environmental pressures, competition for resources, and the ever-present force of natural selection. The drying up of shallow seas forced some fish to adapt to life in oxygen-poor waters. These fish developed the ability to gulp air at the surface, using primitive lungs to extract oxygen from the atmosphere. This adaptation, which would prove crucial for life on land, evolved long before the first fish ventured out of the water. Another key adaptation was the evolution of strong, sturdy fins. In shallow water, fins could be used not only for swimming, but also for pushing off the bottom and maneuvering through dense vegetation. Over time, these fins evolved into limbs capable of supporting the weight of the body on land. The transition to land also required adaptations for locomotion, sensory perception, and reproduction. Fish that ventured onto land needed to develop new ways of moving, finding food, and avoiding predators. They also needed to evolve ways to reproduce without relying on water to fertilize their eggs. One of the most critical challenges facing aquatic animals venturing onto land was the need to breathe air. Fish use gills to extract oxygen from water, but gills collapse in air, rendering them useless. The evolution of lungs, organs capable of extracting oxygen from the atmosphere, was therefore a prerequisite for life on land. Remarkably, the ancestors of land vertebrates already possessed a primitive lung. This lung, however, was not used for breathing. Instead, it functioned as a swim bladder, a gas-filled sac that helps fish control their buoyancy. Over time, this swim bladder evolved into a true lung, capable of exchanging gases with the atmosphere. The evolution of lungs was a gradual process, with early lungs likely being simple sacs with limited surface area. Over time, natural selection favored individuals with more efficient lungs, leading to the evolution of lungs with increasingly complex internal structures and greater surface area for gas exchange. The development of lungs had a profound impact on the evolution of land vertebrates. It allowed them to exploit the oxygen-rich atmosphere, providing them with the energy they needed to move, hunt, and survive in their new terrestrial environment.